This is my project on experiment 4, the reaction rates. It was ran today. So the materials we used were vinegar, baking soda, timer, also some cups and other stuff that was used along the way. So my hypothesis was that I think that cold conditions are going to be slower than room temperature, and that hot conditions are going to be faster. I think this is because that molecules speed up when they're heated. They like separate more, and move around a lot faster than they would do if they're just like room temperature or cold. Cold makes them slow, kind of like all banded together. And I also think that with less reactants, no matter the condition, even if it's hotter, colder, room temperature, in this case it's room temperature, it will always be slower because there's going to be less of a reaction because there's not as much mixture to make a reaction. So the constants are the amount of baking soda we're using, the type of vinegar, and the same procedure and timing. And variables are the temperature of the vinegar and the concentration of acetic acid. So for my room temperature data, it took a minute and 43 seconds to get a reaction. And some of the observations I made from this was there was fizzing upon when the, the chemicals mixed together. The bubbling started off really strong, but then died out over time, and there was a cloudiness within the solution as the bubbles were rising. For my cold temperature data, it took 2 minutes and 50 seconds to get a reaction. The observations for this one were that the bubbles were forming way more slowly than they did at room temperature. The fizzing was quieter and way more subtle. The bubble sizes were smaller, and the reaction itself was also smaller. So for the hot temperature data, the time it took for a reaction was 33 seconds. The observations we made for this one was there was rapid bubbling that began instantly. The fizzing was a lot more intense and violent, and it was a lot louder than the other ones. And there was large amounts of foam and bubbles that formed really fast at the very beginning. For the diluted reactants, it took 2 minutes and 3 seconds to get a reaction. The bubbles formed way more slowly, but they weren't as like violent. They were like really calmed. The fizzing was a lot more quiet and was a lot more spread out. It wasn't like they were all fizzling at the same time. It was like a little bit out, like all like over a longer period of time, and there was fewer bubbles produced at the beginning, and they were rising slower. So my conclusion was through using different temperatures, we were able to test the effects it would have on the reaction between vinegar and baking soda. The room temperature reactant took about 1 minute and 43 seconds, and the colder temperatures it took longer, and then the warmer temperatures it was a lot faster. When we diluted the formula, it also took longer, and all of this is correct with my original hypothesis that warmer temperatures means faster reactions, and cooler temperatures and diluted formulas result in a slower reaction. So some errors that were found was that there was inconsistent vinegar concentrations. If the concentration was not exactly 5%, or if the dilution was not done correctly, it would have an effect on the reaction times and the temperature fluctuations if the vinegar wasn't kept at a consistent temperature throughout the experiment. That impacts the reaction times and also makes the results unreliable. And that one improvement for this would be to increase the accuracy and the precision of this experiment would be to use temperature-controlled water bath for both the hot and cold vinegar solutions. It would help maintain a consistent temperature throughout the experiment, reducing the temperature fluctuation and ensuring that the reactions occur at the intended temperatures. This would ultimately lead to more reliable and precise results. So, for the first question, which which reaction was the slowest and which one was the fastest? I said that the slowest was the cold temperature in the experiment, and that the fastest was the hot temperature one. I said that it makes sense because when molecules get heated, they move faster and like bounce off of each other a lot faster. And when something gets cool, the molecules move slower, and they're always like more bunched up than they would be if it was in warmer conditions. For the second question, I said that the hot temperature seemed the most violent because the molecules were already moving fast due to the heat, and that the diluted seemed the most calm because there was less of a reaction than there would be with the cold temperatures and stuff like that. And for the third question, um, I think it does support my findings to question one. I said it does because the most violent was the fastest reaction, and having less of a reaction, even if it's a different temperature than the slowest reaction, um, it seems more. It was more calm. It felt like it was more controlled. Yeah, that's it.